Okay. Um, so we've shown how to use the law of sines for an angle-side-angle relationship. If you ever had an angle-angle-side relationship, you could do the law of sines as well. We also mentioned that the law of sines can be used, sorry, where was that? The law of sines can be used for a side-side angle or an angle-side-side relationship, right? It can be. And this is what is called the ambiguous case. So let's look at, here's the mechanics, or here's the physical reason for what we call the ambiguous case. The word ambiguous means you're not sure how to interpret it, right? For us, it means there could be some more than one solution. There could be no solutions, right? It's ambiguous. You're not quite sure how to interpret it. So when you have an angle side, and I'm just going to write this, okay, don't report me. But when you have an angle side-side relationship, that would mean you know one angle and you know two sides, right? And the angle is not the included angle. So for example, if you look at this first picture here, if I knew this angle, right, and I knew this side, and I knew this side, right? Now this third side, I don't know its length. That's why it's dotted all the way over here like this, okay? It's possible in some scenarios, not all of the time, let's be clear, but there's a possibility that when you know this side and you're trying to figure out this angle, you could create a triangle that looked like this with that side length, right? B would be this long. But there's also the situation where if you swing A out to here, it also matches up with this horizontal line, and we could say that this could be B, okay? So this would be a situation in which you could have two solutions to the problem, okay? And we'll talk about what that looks like mathematically once we start going. Now, there's also this scenario, right? Let's say you know this angle. Now, you're measuring it from a horizontal line, but you don't know how long that is. You know what this side length is. You know what this side length is. Well, it's possible that that side is not long enough, given this steep of an angle, to actually hit this other side. So it's possible to not even have a triangle in this regard, okay, because it's not long enough. And that's one of the things I was mentioning before about side lengths in the previous video. Just because you get three numbers doesn't mean you've actually formed a triangle, right? Okay, if you had one side length that was 100, one side length that was 4, and one side length that was 6, if you had a side length for a triangle that was 100, right, and drawn to scale, 4 would look like this, and 6 would look like this, right? That's not, I mean, we formed this triangle, right? But we didn't use all 100 units of that, okay? So just because I got three numbers doesn't mean those three numbers work, right? So keep that in mind when we're talking about the ambiguous case, okay? I did find, sorry, I could mention this, props to, let's see, where was this? This was on Math Warehouse, okay? So I'm going to upload this link to Schoology. It's got, what do you call this, a GIF? Is this a GIF? Oh, it's not letting me. I'll go over here. Of this scenario that I was just talking about here, okay? And this is, I went through this once. There's another video here explaining it and a bunch of other stuff going on. This is just as good as what I'm going to give you. So I added this link because I think it's really good. I mainly was just looking for one of these animations of how this is possible, okay? And you can see this is how we can form. We can form an obtuse triangle. We can form an acute triangle in the ambiguous case. So I'm going to add this link, props to mathwarehouse.com. I'm going to add that link to Schoology so that you guys can see that GIF. And there's another video here embedded in this, which is good, along with a little more explanation. So probably better than what I'm doing.